getting a little better maybe at solving and remembering how to factor things. Let's look at some other stuff here. So more of this zero product property, right? So anytime you've had A times B equaling 0, what do you know about either A or B or both? Or both, right? And so when you have factor times factor equals 0, you set each factor equal to 0 and solve it for the x or whatever the variable is, right? And then here they're going to do some higher order polynomials, like instead of x squared, we might have an x cubed. We've seen that before, right? All right, so they want us to solve this using factoring. I mean, we can solve graphically, right? Like the ways to solve an equation, you graph it, right, and see where it hits what? No, like we're looking for the zeros, right? So if you graph it, you want the solutions, i.e. zeros, that's where the graph hits what? Yeah, the x-axis, which is a 0, y, right? Okay. There's other ways to solve these things, too. I think next section or next book, we use a quadratic formula. I can't remember now. But anyway, let's factor this thing. Is there a GCF in A, the x squared plus 2x minus 35? No, it's a trinomial, so we'll just get halfway done, right? So what are the numbers that go in the two spots? So 6 and negative, so 6 times 5 is what? Right. Now, again, sometimes I like to just think of the numbers without the signs first, right? When we first get them. So I know 7 times 5 will give me 35. And 7 and 5, I can get to 2 with it, right? Because there's a difference. So one's got to be positive. So plus 7 minus 5. And now what do I do with these two? It's an A times B thing, right? What do I do with them? Set them each equal to 0, right? I don't know. It's 8.7. What does x equal? Negative 7, or x equals positive 5. Okay? And by the way, if you're going to, you remember the set notation? Negative 7, comma, positive 5. You don't have to use that, but remember you might see that. And if any of you go on to college and major in math, you probably take a course called set theory and use that a lot.
Use what?
Set brackets. But anyway. All right, how about part B? We just get halfway done here like we did with that, or is it a little more complicated? You can factor out a 3? That's nice. Because maybe you think, I got to use the 8 times C method, right? But 3 goes into all 3 of these here, doesn't it? So we could do it with the parentheses, couldn't we? Or we could just divide every term by 3, right? That's another way. Either way is fine with me. And also the other side, right? When you do that, it's got to be all the way across, both sides of the equal sign. What does that leave us? Plus 16 equals 0. Right? You guys go ahead and factor that quietly on what you got. Don't get sloppy with your math. Side equals 0 all the way down. Right? I'm not doing chicken scratch off to the side or anything like that. Serenity, do you have the factors yet? Well, x, I just want the factors. She said x minus 8 and x what? Plus 2? Well, that would multiply to negative 16, right? They're both going to have to be negative, aren't they? Because what's a negative times a negative? So positive 16 they multiply to, and they add to negative 10. And so x minus 8 equals 0, or minus 2 equals 0. So what does x equal? 8, or x equals 2. And you can put it in a set there if you want. Doesn't matter. All right. Hey, what about C? That was pretty nasty. But maybe not so nasty. Are we still just going to see if we can factor it? How many terms are here, by the way? No. 2. Remember, terms are separated by addition of subtraction. That term and this term here, right? Okay. So, Amy, do you see any common factors between this term and that term? The x minus 3 is common to both, so can we factor that out? Yeah. So let's factor out an x minus 3, and what remains? So x plus 1 plus 2x minus 7, doesn't it? Equals 0. Remember that? We don't need the parentheses around them anymore. If there were some, like if this was subtraction, I definitely have to do minus parentheses, that one, right?
Why did you why is it,
Like, what?
how did you get just 1x minus 3?
I factored it out. Forget that it was an x minus. Try it. Think of it this way. You don't have to write this down. Instead of x minus 3 out here, what if, God bless it. Not wanting to work. Instead of x minus 3, maybe this is a 5 and a 5 times that and 5 times the other. And 5 is a common factor, so I factored out a 5.
So you just get, that makes zero sense.
What if I have 5x squared plus 10 x? Let me just 5x squared plus 10. What's the common factor? What's left inside? X squared plus 2. Isn't that what I just did? What's left in here? That and that.
You have to count factor out by all of it.
There's 2, maybe that's what you're not seeing. There's only 2 terms in here. Let me get rid of this thing.
Why did you keep the 1 term? It was just
Well, I did.
yeah,
I
but
think you're
still,
getting
no,
confused because
why is there, when it's still there, you got rid of it?
when you factor, you're not getting rid of it. In fact, when I did this, good gravy, 5x squared plus 10. Did I get rid of the 5? It just went outside the parentheses. Like that, it didn't get rid of it, right? You see what I mean? So instead of a 5, it's just this.
You're not getting it out of, there's no common factor of x minus 3.
There's this term here
2x minus 7.
and that term there, and they have a common factor together of that x minus 3. Right? Separated by that plus sign. Like this is separated by that plus sign, right? Right? Factor and factor. What? Okay, maybe if I do it, I have. If I do it this way, let me factor out the x minus 3. And then inside, right, if I take this term, this first term, and divide it by x minus 3, what's left? My x plus 1. Plus, if I take this term and divide it by x minus 3. What's left? 2x minus 7. Does that help? Okay. If I take the 5x squared and I divide it by 5, what's left? X squared. If I take the 10, divide it by 5, what's left? Oh, that should be 2. That should be 2. Sorry, 2. What's left? 2. That's all I did here.
But still, I don't understand how you added 2. Because you divided 10 by
That is that plus sign.
You know how like the graph has like the two numbers like they're like the same thing on the I think the y-axis. Like the -3, -3. Is that the same thing? You're a teacher.
I don't know what you're asking.
You know how like you would plot the things like Equifax, whatever else there?
Uh-huh.
And like the y-axis has like the same like -3, -3, and like the middle number which is like 1 now. That'd be like the same thing.
Yeah, I'm not sure that I don't know.
Okay, so you're graphing.
Okay. Yeah, the x-axis and the y-axis.
Yeah, okay, and then you have a graph. Okay, the 2 points on each side of the graph are the same, yeah. the
On a
same-
parabola, you mean?
Yeah.
Symmetrical.
And like how that, it's both threes. Like, you know what I mean?
I don't, okay, I think I see what you're getting at, but not exactly, because what you're assuming, I think, is the parabola is centered right on the origin or right around the y-axis, symmetrical there. But, so I don't think this is the same as what you're getting at there. Well, let's finish this out and maybe it'll help answer what you're asking. So let's combine like terms in this method. Tegan, do you understand this part here? It's the same as this. It's just with different looking stuff. That's all. Let me get rid of this. Sweet Maria. That's going to do that. There we go. Okay.
I think you did.
Yeah, I don't know.
Those things kind of go to.
So x minus 3. Let's combine our like terms in here. What do we got? Combine like terms.
2x or 3x
3x
plus or minus 6.
minus 6 equals 0. Now we have a factor. What do we do now?
How'd you get 6?
1 minus 7.
Now you multiply it by the.
1 minus 7 is negative 6.
1 plus 2 and then 1.
No. These are like terms, and these are like terms, right? Okay? So now we set the factors equal to 0. Or 3x minus 6 equals 0. And I'll go up here. So what does x equal on this side? X equals 3. Or add 6 to both sides, you get 3x equals 0, or 3x equals 6. So what does x equal? 2. All right? I didn't anticipate that one becoming such a mess there for you, but hopefully you can get that. Now, this is really just, it's just factoring out the common factor.
That's
It
what makes sense. That's how.
just looks a little different than,
Wouldn't you just multiply wouldn't you just factor the, I don't know if it's factor, but I can't think of the word.
let me try it this way. Anyway, let's go on to exercise 2. And the people at home did not get the privilege of viewing all of that. But anyway, James graphed the quadratic 3x squared plus x minus 10 using his calculator and the table of values. He can tell from his graph that, and the table that x equals negative 2, that's this right here, is one of the zeros. Why is what?
Why is my dad open to?
We're not, that's a circle, that's indicating I'm talking about that point kind of circle, not a graph circle.
Two.
Alternatively, I suppose I could have done that. And that's what I meant by the circle, okay? And I think that's what they mean by this circle over here, because we're going to talk about that point in a minute. All right? So x equals -2 is one of the two zeros. What's the other zero here? Now, do you see this one that's circled? And the circle is intended to bring your attention to it, not as an open circle on a graph. What is the value? So this is x over here, clearly of -2, because it hits the point exactly, right? What is the value? Look closely at it. What is the value of that?
It's like 1 3/4.
So it's hard to tell, isn't it, right?
Yes, it's not right on too.
So like solving graphically has its limitations, doesn't it?
Yeah.
If your roots don't fall right on an integer number on your graph, okay? So what we'll have to do is solve this thing algebraically. And by the way, knowing that one of the zeros is -2, what's one of the factors? So for example, like you see where this is x equals 3 is one of the roots up here? What factor did that come from? X minus 3, right? Okay. So if one of the roots is x equals -2, what factor does that come from? It comes from the factor x. No, that's not a factor. X minus 2?
X plus 2.
Plus 2, because when you set it equal to 0 to solve it, you get x equals -2, correct?
Sure.
Okay. Now they want to ask, they want to know, how does knowing that that factor is x plus 2 help you find the other factor? I don't think I really want to do it their way. Part A, write down an equation that will allow you to solve the zero for this function. I don't think so. I think their way is a little harder to think about. I think I want to do it in a way that we've already done this before, so it's in your head and should therefore be easier, I think. So let's do the first part. Part A. It says write down an equation that will allow you to solve for the zeros. So here's our function. What would be our equation to help us solve for the zeros? There's not going to be a what? The zeros mean that y is going to equal what? Y is going to be 0. So 3x squared plus x minus 10 equals 0, or y has to be 0 to find the zeros. That's what we're getting at. So now, yeah, I don't really want to do it there. We know that x plus 2 is going to be one of the factors, right? So let's just factor this. Is there a GCF? So what method do we have to use here? Okay. What's A and what's C? What? 3 and -10, which gives you -30. So I need factors of -30 that also add to what?
-10.
No.
That's 1.
1. It's a 1x, right? So what numbers multiply to -30 and also add to 1?
What is -5?
Say again? 6 and -5. So let's check. 6 times -5, is that -30? This? That's a 3. It's the same as up here. And what is 6 minus 5? Right, so, right, because that's a 1 there, isn't it? Okay. So this is just, now we're going to rewrite the equation. So it's gonna be 3x squared plus what, everybody?
Wait, I don't know what the x plus 2 is that.
Well, what?
John, if you already know x plus 2, I have to erase it.
Did you see me erase it?
No, I didn't see your erase it.
Well, do you see it there anymore?
No.
Then I must have erased it, and so will you. Remember, I changed my mind about how we're gonna do this one? Okay, so plus 6x what? Minus 5x minus 10 equals 0. See, isn't this my 1x? 6x minus 5x? And we're what numbers? Which half? Well, this is from the equation they gave us.
6 times 5 negative 5 is 30. 7 and 6 plus
So, Amy, this has, the X word has something other than 1 in front of it. And there's no GCF, so we have to use that AC method to factor. Greatest common factor. You can't divide it, you can't factor a 3 out of all, right? So we got to use the old A times C method. A and C multiply to negative 30. And then you find two numbers that multiply to negative 30. No, I didn't get the 5 from the 10. That's not a 5, that's a 5x. So 6 times negative 5 is that negative 30. And also 6 minus 5 equals our 1. So I take this 1x and I rewrite it as 6x minus 5x. Isn't this 1x? What's 6 minus 5? Okay, that's the 1x. I just split it up into 6x minus 5x. And that stayed the same. Okay? So this is what we learned a while ago, the AC method. Now we factor by what?
You really do get it.
It's not something.
Wait, hold on, I think it's just the operator.
Yeah, that's what it is. Or it could be the viewer. Okay, let's factor by grouping. Factor out of 3x. What's left inside? X plus 2. Next group. Factor out of negative 5, leaving us x plus 2 equals 0. Okay? Oh, yeah, now it's down. We'll just move down here. Where they saw, I hate when they break it up like that, but okay. What's the common factor between these two terms? X plus 2, leaving us 3x minus 5 equals 0. Now what do we do? Set them both equal to 0. So either x plus 2 equals 0 or 3x minus 5 equals 0.
I wrote this in the wrong.
It's okay. X equals what? Negative 2. Or add 5, you get what? Bless you. 3x equals. Does anybody know what 0 plus 5 is?
5.
Okay, thank you. And what do we do now? Divide by 3, you get x equals 5 thirds.
I get a 5.
If I add 5,
Divided by 3.
what now? What? Ask me one question at a time. I'll address it and then ask your next question. That's not going to be negative 5 because I added 5 to both sides. Right?
Yeah, but I understand it now.
And then I divide both sides by 3.
I forgot you had to divide by 3.
When I,
So I thought you were just switching it like x equals negative 5.
this is plus. This is the part I don't write anymore because I kind of assume everybody gets it, right? And I don't do this divided by 3, divided by 3, right?
Is that right?
Dividing by 3 undoes multiplying by 3. So, yeah, exactly. You're solving. You're doing what undoes the things, huh? I'd have to see what it was. But you understand adding 5 both sides divided by 3, right? Okay. Now, This doesn't help us graph it, so let's write that as a mixed number. How many times does 3 go into 5? Once, how many left over?
2.
So 1 2/3. Right, so now I put it as a mixed number because now here's our -2 and this is what? 1 2/3. Why is it negative? Just solving, subtracting 2 from both sides. So x equals -2. Yeah, I don't want you to think of it as just switching the sign, just because you're subtracting 2 from both sides. I know, but that's not mathematically perfect. So, all right, anyway, let's move on. Okay. Next page. Now we have we have a cubic, a higher order, okay? Now before we start this, we've seen it quite a few times. You remember how to factor a difference of 2 squares? It's kind of like the fact that you guys aren't remembering this is troubling me a little bit because we do a million. How does this factor? A plus B times A minus B. All right, we've done those quite a few times. That's one way to factor. So we have a cubic function now. X cubed minus 9x, right? It's not quadratic anymore, is it? So we're going to find the zeros, just like we did with a quadratic. So we're going to take this x cubed minus 9x and set it equal to what? To find the zeros. X cubed minus 9x equals 0. Okay, let's factor it. It's not quadratic or trinomial, so it's not going to be 2 sets of parentheses. Wait, no, it's not going to be 2 sets of parentheses. These are not 2 perfect squares. X cubed is not a square. Guys, what's the GCF between the 2 terms? I mean, here. Greatest common factor. It's x. 3x. It's just x, right? Okay. No. Because we had, remember, it has to equal 0 to solve it because there's an x cubed and just an x term. So
That would be 3 times 3 times 3, wouldn't it?
What? What? Where are you getting 3 times 3 times 3? No, 9 is not 3 times 3 times 3 times 3 times 3 is 27. That's a cube. It's not a square. So it's not a difference of 2 squares. Yet. Okay. What is x cubed divided by x? X squared minus, what is 9x divided by x? 9 equals 0. Now, you see that thing in the parentheses now? Is 9 a perfect square? It is. What's the square root of 9? Now it's a difference of 2 squares. Now we have a squared minus b squared. I'm not going to argue with you at all.
How did I get that?
So x times what? There's no a's in here. X plus 3 times x minus 3 equals 0. There's your difference of 2 squares. And now we have 3 factors. What do we do with them? Set them all what? So we got x equals 0 or plus 3 equals 0 or. So this one's already solved, isn't it? What does x equal here? -3. You guys subtract 3 from both sides, right? Or x equals +3. like that. Hey, by the way, is there a shorthand way to write these two together?
Plus minus, yeah.
Yeah, I could really write x equals 0 or x equals plus or minus 3. Either way is fine. Okay? Okay. Now, put this in your calculator and graph it. See what do you remember what it looks like? It's a cubic. Is it going to be a parabola?
What is that?
What? You see the window you need to use here in your calculator? Fix your window so you can see the whole thing. You know how to what? What thingy? Would you kids use words other than thingies? What?
I was writing this down.
Problem set.
Yeah, the problem set.
This?
Yeah, now I got it.
What's taking you so long?
No, that's no problem.
Okay. Tab. Let's put this in here.
That is very weird.
It's x to the third, right? What was it? Minus 9x?
Minus 9x.
X. Oh, I see what I did that too. Like when you use that thing, you
Yeah,
got
that's
the,
what you.
yep, minus, when you use it like squared one, it doesn't do that. 9x. Let's get the window to fit. Menu, window, it's a graph.
It looks like an
It's a graph. -5 to 5. And what was the -15 to 15? There.
Oh, oops. I had the wrong thing.
So where are the zeros of this graph?
Right where it hits.
Right? So let's look. So it looks like this. Let's put that in there. So our zeros, by the way, let's mark them on the graph from our solution. We have one here at x equals 0. Where's the other one?
3.
At 3. So 1, 2, 3. There's one. And -3, right? There's the other one. And so let's put our graph in here. Okay? That's what an x to the third function looks like. Cubic. Okay? And here are the zeros. -3, 0, and +3, which is what we got when we solved it. Those are the roots. Okay? So this stuff works for things other than quadratics as well. All right? Side relief.
Math is confusing. Minus the side tired.
Okay. Let's move on. So yeah. Anyway, what are they doing here? We got quadratic x squared minus 8x plus 15. Why don't you guys work on this one? Okay. So find the zeros, which means you're going to take this function and make it equal what? X squared minus 8x plus 15 equals 0. Now this is a trinomial, right? It's just going to be two sets of parentheses, get halfway done, right? So go ahead and get this thing factored.
Is it 3? Oh, it is 3.
What multiplies a +15? Adds to -8? Hannah, what numbers multiply to 15 and also add 8? Forget the signs right now. Hannah, you can't tell me some numbers that multiply to 15.
3.
Hannah, 5 and 3. Okay, now if you were to add 5 and 3 somehow or other, can you get 8?
Yeah.
Okay, so you're on the path, but we got to add it to -8.
So it would be negative
So negative,
5 and negative 3.
negative 5 and negative 3. Do they multiply to positive 15?
Yeah.
Yes, they do. All right. So x minus 5 equals 0, or x minus 3 equals 0. So what does x equal? 5. Or x equals 3. Okay. Part B. What is it they want us to do in part B?
For a quadratic function, vertex form and identify a quadratic
Identify the what snows?
coordinates.
Of the
Of its turning.
vertex, right? You remember how to write it? We just did it. How do you get this thing written in vertex form? You must,
Make it equal 0.
no, you complete the square. Equals x squared minus 8x plus something. Plus 15 out there. Well, yeah, we're going to complete the square though. What do we add and then immediately subtract?
5.
No,
Add the 8.
no.
Add the 5. Oh, no.
B over 2 squared. So, Mason, what are we adding? Squared. So 4 squared, right? It's negative, right? But we're going to square it, so it doesn't really matter. So add, so 4 squared,
Minus.
and then immediately subtract it. Okay?
Why'd you do minus 16? Because
What's 4 squared?
16.
That's why. It's not?
So it's negative 1.
Oh, I thought you said no. Okay. What's this become?
I'm starting to worry about you guys.
What's this become?
There's like 0 in the first place. Do I? Y equals x squared. No. X plus minus 4. X plus squared. Minus 1. X minus 1. I just said that.
It's not like we didn't do 153 million of those.
How old is that?
Huh?
You can't count all of them, is it?
What are the coordinates of the vertex?
4 and negative.
This is when you put the sign, Amy. 4, positive 4, comma negative 1. Maybe that's what you're asking. So the vertex is at 4, comma negative 1. Okay.
What is true about the x?
All right. You have become a rapid reader. So here's the zeros. 5 and 3. What's the x coordinate of the turning, the vertex?
4 is negative 1.
No, the x coordinate is just 4. So think about that 4 in terms of the 5 and 3. Where is that 4?
In the middle of them.
It's exactly halfway between 3 and 5, right? So that 4 is exactly halfway between 3 and 5. Okay? Wouldn't you say 4 is the average of 3 and 5? Or how to take an average? Please tell me you know how to take an average of 2 numbers.
You add them and then multiply by 2. Divide by 2.
You add them up, divide by 2, right? So wouldn't you? So isn't that 4 the average of 3 and 5? Right? What's 3 plus 5? Divided by 2.
4.
Okay. Let's make a rough sketch of this thing here. Okay. So We know where the roots are, right? Where are they?
In the ground.
2, 3. Yeah, your mom. 5. Here's 1. And where's the other root? Where's the other root? So one of those numbers is 5, and I put that on there. So the answer to what's the other one must be,
3.
okay, there we go. All right. And now what are the coordinates of the vertex? So put it there. So 4, -1. So would this be roughly our parabola? Now, let's draw the axis of symmetry through there. That's the symmetrical axis. So this is 4, -1. What's the equation of that line, that axis of symmetry?
Oh,
Well,
x equals 4.
Yes. What axis does it cut through?
Y or X.
And where does it cut it? At 4. So if you know what the roots are, how can you find where that axis of symmetry is?
Hi, Emily, you missed a lot.
Because the axis of symmetry is exactly where?
On the x-axis.
Yes,
That's the one.
it is not. The axis of symmetry is exactly where?
Halfway.
Halfway between what?
3 and 5.
The roots. Or it's the average of the roots. Or do you remember this? Remember how I gave you the equation for the axis of symmetry a while back? Equals -b over 2a. Do you remember that from way back? Again, the axis of symmetry equation. What's the b in this equation? No, it is not. So, no, it is not. It's just -8. So x equals -8 over 2 times what? What's the a? What's the a?
Oh,
1.
1. Yes, 1, guys.
What's -8? Divided by 2 is, hey, how about that?
Whoa.
So there's a little formula for the axis of symmetry. The axis of symmetry is exactly halfway between. Okay?
Yeah.
All right. Well, probably the best thing we can do is move on to this one. So think about where the axis of symmetry was. It was the average of the 2 roots, wasn't it? Because it's exactly half. Isn't it an average of 2 things exactly halfway between the 2 things?
Yeah.
Right? And how do
It's
you
5.
find the average of 2 numbers? Add them. That's it.
It's 5.
So you take all your averages of things by just adding
You
them.
add them and then you divide by 8.
By 2, yes. It's 2 things. You add them up and divide by 2. So half, right? So read this one. You said that's supposed to. Anyway, it's not important.
I think it's 2.
Oh, okay. Yeah, okay. The x-coordinate of its turning point, vertex, or the equation of the axis of symmetry. Now, let's solve this thing. Find the roots, because we know that that's going to be halfway between them, right? What's this root? -3. What's this root? And we know it's going to be exactly halfway between, so we can take the what of those 2 numbers. So let's do the average of the roots. -3 plus 7 divided by what? 2 equals somebody?
2.5. Maybe it wasn't 2. Oh wait, 2. Yeah.
Yes.
That's 4.
That's 4 over 2, which is 2. So the equation is x equals 2 is your axis of symmetry, because it's half. So if you have the roots, just take the average of them, and you've got where the turning point is. Well, the x part of it. So x equals 2.